All right, my name is Paul Kaler. I'm a future storage architect for HPE. I'm going to be telling you a little bit about why we created this spec. We've got a couple of our other co-authors up here of the spec, Yong from Meta and Lee from Microsoft. They'll be talking a little bit later about some details in the spec and call to action. All right, so why did we create this spec in the first place? For some of you that are familiar with the NVMe data center spec, this will seem very familiar to you. Right, we've already got industry standard specs that cover SAS and SATA. Everybody is familiar with T10, T13, and SATA I/O. But what the real problem is when device vendors come and they actually try and build a device, they need to figure out, well, what features, right? These specs are very feature rich. They include everything. What do the customers actually need? What do data center customers require? What command sets? So those are some of the problems with the current approach today. And that's because there are no publicly available customer specs for SAS and SATA devices today. And that's because data center customers traditionally have their own proprietary specs and they're confidential. And of course, there are some issues with that, right? That discourages industry innovation because lots of times you have IP related to those custom requirements. Those have to sometimes be developed in silos. So you wind up getting a lack of collaboration among the teams that are developing these devices, and that generates a bunch of extra industry work for very little added value. In addition, test cases, customers trying to figure out how robust can our devices be. It's very hard for the industry to generate relevant test cases because they don't know exactly what's in the device. So they have to either put everything in there, which then is a huge amount of extra work. They don't know exactly what to test. And the lack of collaboration in general just slows innovation. So the solution was that Microsoft, HPE, and Meta all got together and merged all of our requirements into a single specification. We got one big update we can share with you today, that this specification, some of you may be aware of, it's been in progress over time. It now includes both hard disk drive and SSD for SAS and SATA. We are planning to contribute it the Q4 of this year, so it's coming just around the corner, coming soon. Kind of keep your eyes peeled for that. Now to talk about some of the benefits, really now we can standardize all the requirements that you guys are trying to build into a data center SAS or SATA device. You know exactly what command sets and features to put into that. This, of course, enables more industry collaboration and lets us innovate on new features and technologies instead of having to spend all those resources developing multiple firmware versions for all the different customers. That, of course, leads to a reduced development and qualification resources, kind of get to that proverbial one firmware to rule them all. Now we can focus all of those resources on developing, common firmware, common device, and you're not separate with a bunch of silos for all of those different customers. On the test front, it enables third parties to actually get some really good value because now they know exactly what's going into that device. So they know what feature sets to put in their test suite, and now we can get really good tests developed without having to interact with individual customers on a customer basis. They can just read the spec and know exactly what they need to put in there. In addition, much like with NVMe, we have the NVMe CLI open source tool for doing configuration and management. Now this also enables open and third-party tool development if you want to be able to do management of your SAS or SATA device, or if you're trying to do configuration. All of the feature sets that are included are there, easy to read, and so now we can get these open source tools, which will be great. And of course, all these industry benefits are twofold. They're great for the suppliers and they're great for the customers because with all of this increased knowledge and collaboration, that means we can get increased innovation. And that really leads to us getting devices that have more features, better quality, and faster time to market. And really, the end result of all of that is by leveraging all of our economies of scales, we're really hoping that we can, as an industry, get to lower overall costs. All right, so Yong, let's talk about what's in the spec.
Thank you, Paul. Yeah, as Paul just mentioned, we have Microsoft, HP, and Meta has merged all our requirements into one document. So our expectation is we want to make our life simple, right? So you might be curious what is in there. So it's basically defined from the use case perspective. We are defining all the requirements for the SATA devices, including HDD and SSD, but it's mainly on the SATA. So we have a different spec on NVMe devices. Here, the areas in the document we have, I'm trying to go through one by one. The first one is the interface requirements. It's basically define how the device should communicate with the host in terms of SCSI commands, other commands, log pages, how we communicate. It's mainly on the protocol-wise. And also, I will go into two of the areas in more details in the next two slides. So the next one is the power. So we also, like most of our data center use cases are limited by the power consumption overall. Even the hard drive is not very power hungry, but again, we have very detailed requirements on this, say 12-volt real or 5-volt real. So, and the next two is the reliability performance. It has a great dependency on the data center workload and the data center environmental conditions. So I will also go into a little bit more details in these two sections as well. And in the environmental sections, we basically specify how does a drive performs in the environmental conditions, including the thermal, the humidity, and also the vibration conditions, as Zakia just introduced, right? So the drive operating in our chassis will be sensitive to the acoustic vibrations imposed by the fan speeds. So we also define from the performance perspective, right? So how does a drive performance look like? How much degradation we are allowed under different conditions? Same thing to the temperature, humidity. So usually in the past, if we look at the HDD spec, it actually has very strict definition about, hey, this is how the drive operate under certain temperature and a certain humidity. But in this kind of, in our spec, we are trying to assume we can achieve this performance, achieve all those in a wider range. And also security section, this is the key part where we want to make sure our users can trust us in saving the data in our devices. So in which area we actually define how the SAN phone run is required, secure boots, TCG OPPO requirements are all there. In next two sections, like labeling, compliance, yes, we also define the labeling things. And basically, we also require, from an operation point of view, we require like what contents should be on the label and what format we should follow. Like, are you going to use barcode or QR code or whatever for easy data center operations? Okay, so yeah, until now you can see we have a lot of requirements on hard drives, SSDs, those kind of SATA devices for specific use in data center environments. All those requirements are sorted by ID number, so this is mainly for easy collaboration with third parties, with different partners, so that we can refer to each of the requirements in an easy way. So in this slide, I will go into a little bit details about what is in the interface requirements. So as I mentioned, we specify the revisions for the industry standards. Specifically here, we're mostly referring to SCSI, other command sets, standardization from T10, T30, and also serial ATA requirements from the SATA I/O. We also define what features could be optional, what features is required, same thing to log pages or commands. Some examples like the smart data is a must for data center devices, right? If for client usage, they seldom to look at the smart attributes, but for data center use cases, we monitor it every day. We want to make sure the device is performing in a healthy state in our data center. Another example is like free fall detection, maybe a good feature for laptop use cases, but we seldom detect this kind of events in our data center use cases. So those are examples like, hey, when we use hard drives in our data center environment, it's kind of a different features we want the hard drive to support. There are some other configurations, operational requirements I have also listed here, like write cache management. When we enable write cache, we want to maintain the data integrity. We want to also ensure the drive performance when the hard drive is trying to flash the cache to the disk. Firmware download or firmware upgrade, that's also an operation task. So we want to make sure. So we are able to download the firmware with concurrent IOs, and also we have latency requirements. The other two bullets here is also on the tail latency in a collective operation way. So error recovery, background activities, we want to make sure that when the drive try to recover some software errors from the disk, we require the drives should be able to complete it within a certain time so that we are not going to see very long tail latency from the drive perspective. Same thing to background activities. We want to control how frequent the drive can kick in the background activities. SMI configurations may also have depend on the customers. We probably require different over-provisioning, different ROM size on SMI drives. Interface speed is pretty standard, 6 gigabit per second for SATA and 12 for SAS. Next, the performance reliability is also very critical for data center operations because it depends greatly on the workload. Also depends greatly on the environmental conditions. So we have very specific requirements on the latency, especially the tail latency, the IOPS, the bandwidth for data center workloads, and also the AFR or MTBF, those kind of reliability requirements we also have specified here what temperature range, what humidity range, what kind of workload here we want to achieve this kind of AFR for a wider range. This is definitely higher than how we define it today for client use cases. And there are some certain reliability metrics that are also key to data center operations. So load unload cycles is one. In some cases, in some archival use cases, you probably want to power off the drives very frequently. So we have defined the max number of load unload cycles the drive can support. EPO, emergency power off, is where we also want to maintain the data integrity when you suddenly see the power off in an unaggressive way. Uber and uncorrected bit error rate is also another reliability metrics we need to define to make sure our AFR can meet our spec. And head degradation is probably, you can test common failure modes in our data center environment. So we also want to make sure even a head degrades. So you should have a certain requirements to say this head is not as bad as to be a bottleneck of the drive performance or to cause the whole drive to fail. Right. So those are the examples of the performance and reliability metrics or requirements in our defined in our spec. Next, I want to pass to Lee to summarize all the efforts we have done and what actions we will call.
Right. Thank you, Yong. So as you can see, there's a lot of stuff here that we've tried to put together in a cogent manner that allows for the industry to come together in a way that we haven't really been able to do before in the SATA and SAS world. So we've got enterprise and data center kind of coming together. So really what our call to action here is, I mean, obviously review the material, tell us what you think, you know, work on this stuff, you know, if you're a vendor, please adopt it. If you're a hyperscaler or enterprise entity, it would be great if you could put this into your purchase specs. So we're all doing the same thing across the board. And if you're a third-party test house, please implement test suites against this. So we're all kind of growing the pie and making this really solid for everybody. So thank you all for coming.